And welcome to Technology Tap. I'm Professor J-Rod. In this episode, we're going to compare and contrast protocols for wireless network. This is found in A+. Let's get to it. And welcome back, everyone, to Technology Tap. My name is Professor J-Rod. That's J-R-O-D. And this podcast is about the CompTIA exam. So we go over different topics on the CompTIA exam, the A+, Network Plus, and Security Plus. Sometimes we go into Cloud Plus. Well, those are mostly the three that we focus on. And in this podcast, we do questions. I'll pick a topic and we'll talk about it. And sometimes we do a little bit of preaching and encouragement. All right. Again, my name is Professor J-Rod, J-R-O-D, like the baseball player A-Rod, except it's with a J. So on today's topic, we're going to talk about wireless network. We're going to compare and contrast the protocols for wireless networking. So let's start it off. Wireless networking protocols are essential for communications between devices without the need for physical cables. Several wireless network protocols exist, each designed for a specific purpose and applications. On this podcast, I'll compare and contrast some of the prominent wireless network protocols. Leading off, number one, Wi-Fi, IEEE 802.11, right? Wi-Fi is based on the IEEE 802.11 family of standards and is widely used wireless networking technologies that allows devices to connect and communicate over local area networks without the need for physical cables. Here are some key features and characteristics of Wi-Fi. First, let's talk about the purpose. Wi-Fi is designed for local area networking, providing wireless connectivity to devices such as computers, smartphones, tablets, printers, and other network devices. It is commonly used for internet access in home, business, public places, and educational institutions. Its frequency bands. Wi-Fi operates in both the 2.4 gigahertz and the 5 gigahertz, the 2.4 and the 5 gigahertz frequency band. Some newer Wi-Fi standards, such as the Wi-Fi 6, which is 802.11ax or AX, also introduce support for the 6 gigahertz band to reduce congestion and improve performance. Next, we'll talk about modulation and data rates. Wi-Fi uses various modulation schemes to transmit data, including QAM, QAM, quadrant amplitude modulation. Dual rates vary on the Wi-Fi standards. For example, Wi-Fi 4, 802.11n supports data rates up to 600 megabits per second. Wi-Fi 5, 802.11ac can reach several gigabits, and Wi-Fi 6, 802.11ax supports even higher. Range. The range of Wi-Fi depends on factors such as frequency band, transmit power, and environmental conditions. Typically, Wi-Fi has a range of a few dozen meters indoors, and it can extend to several hundred meters outdoors, right? If there's nothing blocking it, right? Story I like to tell my students is that I was on the 13th floor of a building, and right across the street there was a deli that had open Wi-Fi, and I can log into that Wi-Fi and watch Netflix. Security. Wi-Fi networks implement security protocols such as WEP, WPA, and WPA 2 and 3 to protect against unauthorized access and data interception. Encryption methods like WPA 3 provide stronger security features compared to earlier standards, and you don't want to use WEP or WPA, right? You don't want to use that anymore. Multiple standards. The Wi-Fi Alliance certifies devices for compliance with specific IEEE 802.11 standards. Common Wi-Fi standards include BG, well, this is all 802.11, right? BGN, AC, and AX. Backward compatible. Wi-Fi standards often are backward compatible, allowing devices of different Wi-Fi generations to connect to the same network. However, the network performance may be limited by the capacities of the least advanced device. Interference and congestion. Wi-Fi networks can experience interference from other electronic devices operating in the same frequency band. Congestion can occur in areas with many Wi-Fi networks, leading to reduced performance. Newer standards like Wi-Fi 6 introduce features to mitigate congestion. Wi-Fi is versatile and widely adopted technologies that continue to evolve, with each standard addressing the growing need for faster speeds, increased capabilities, and improved efficiency in the wireless communication. Next, let's talk about Bluetooth, which is Bluetooth is based on the IEEE 802.15.1 standard. And it's a wireless communication technology designed for short-term communications between devices. Here are the key features and characteristics of Bluetooth. Purpose. Bluetooth is primarily used for short-range wireless communication between devices such as smartphones, tablets, laptops, headphones, speakers, and Internet of Things devices. It is commonly employed for tasks like file sharing, audio streaming, and connecting peripherals, like your keyboard, your mouse, right? Audio streaming, like when you're in your car, right? And you want to share your music with your radio off your phone, right? That's a PAN network. Remember that? So that's what Bluetooth is used for. Frequency band. Bluetooth operates in the 2.4 gigahertz of industrial, scientific, and medical band. The 2.4 gigahertz band is also used for other devices like Wi-Fi, which can lead to interference in densely populated areas. Range. Bluetooth has a relatively short range, typically up to 10 meters, for what they call Bluetooth Classic, or 100 meters for Bluetooth Low Energy. The short range is suitable for PAN networks, personal area networks, and limits the risk of interference with other devices outside of the immediate vicinity. Modulation and data rates. Bluetooth uses frequency hopping spread spectrum for modulation. Data rates vary between Bluetooth Classic and Bluetooth Low Energy. Bluetooth Classic supports data rates up to 3 megabytes per second, while Bluetooth Low Energy is designed for lower data rates to conserve power. Power consumption. Bluetooth Low Energy is specifically designed to be energy efficient, making it suitable for battery-powered devices and Internet of Things applications. Bluetooth Classic may have higher power consumption, and we know that, right? Because the Bluetooth is one of those things that will suck your phone battery dry, right? Limiting its use in devices with strict power constraints. Profiles. Bluetooth device uses profile to identify specific functionalities. Common profiles include headset profile, hands-free profile, advanced audio distribution profile, and generic attribute profile for Bluetooth Low Energy. Pairing and security. Bluetooth devices often require pairing before establishing a connection. Pairing involves exchanging security credentials to ensure secure communications. Bluetooth supports various security features, including encryption and authentication. Bluetooth technology has evolved through different versions, with each version introducing improvements in the term of data rates, range, and power efficiency. Common versions include Bluetooth 1, 2, and 3, and 4, 4.1, 4.2, and 5. Mesh networking. Bluetooth mesh is a network topology introduced in Bluetooth 5.0, allowing devices to form a mesh network for extended coverage and improved reliability. Bluetooth is versatile technology suitable for a wide range of applications where short-term wireless communication is required, particularly in personal and Internet of Things devices. The introduction of Bluetooth Low Energy has expanded its application to various low power scenarios. Let's see what happens in the future with Bluetooth. Sounds like we're going to be able to do a lot with it. Next up, we have Zigbee, right? This is probably new for some of you guys. Zigbee is a wireless communication protocol designed for home automation and control system. It is often used to connect and control smart devices within a home, creating a network of interconnected devices. Here are the key features and characteristics of Z-Wave. Purpose: Z-Wave is specifically designed for home automation applications, allowing various smart devices such as lights, thermostat, door lock, sensors, and more to communicate and be controlled within a home environment. Its frequency bands: Z-Wave operates in a sub 1 gigahertz frequency band, specifically in the 868.42 megahertz band in Europe and the 908.42 megahertz band in the United States. This frequency band provides better penetration through walls and obstacles compared to higher frequency bands. Range: Zigbee has a moderate range, typically reaching up to 30 meters indoors. The range can be extended by creating a mesh network where devices act as repeaters, relying messages to extend coverage. Modulation and data rates: Zigbee uses Gaussian frequency shift keying for modulation. The data rates of Z-Wave are relatively low, typically ranging from 9.6 kilobits to 100 kilobits, suitable for the control and monitoring of smart home devices. Mesh network: similar to Zigbee, Zigbee supports mesh networking, allowing devices to form network where messages can be relayed through multiple nodes. This enhances coverage and reliability within home. Interoperability: Zigbee Alliance, a consortium of companies supporting Zigbee technologies, ensure interoperability between different manufacturer devices. Zigbee certified devices can seamlessly work together within the same network. Security: Zigbee includes security features to protect communication between devices. It uses AES 128 encryption for secure data transmission. Low power consumptions: Zigbee devices are designed to be energy efficient, making them suitable for battery-powered devices like sensors. Low power consumption contributes to longer battery life. Application profiles: Zigbee defines various application profiles that specify how devices should be communicated for specific applications, ensuring consistency across different Zigbee devices. Example includes lighting control, climate control, and security. Hub-based architecture: Zigbee typically include a central hub or controller that manages and coordinates communications between devices. The hub is responsible for user interface, automation logic, and integration with other smart home systems. In summary, Zigbee is a wireless communication protocol specifically tailored for home automation, offering features like mesh network, low power consumption, and interoperability among certified devices. It's focused on the smart home market and has led to widespread adoption in the home automation industry. Next, we have cellular networks. Cellular networks include 4G, LTE, and 5G. Our wireless communication system designed for a wide area network to provide mobile device and mobile services. Here are the key features and characteristics of cellular network. For the 4G LTE is designed to deliver high-speed mobile broadband service, offering faster data rates, lower latency, and improved spectral efficiency compared to earlier generations. Operates in a range of frequency band, including low 700 megahertz, mid 1800 to 2100 megahertz, and high 2500 megahertz bands. Multiple frequency bands allow for increased capacity and coverage. Data rates: provides high data rates with theoretical peak speeds reaching several hundred megabytes per second for downloads and uploads. Supports multimedia applications, video streaming, online gaming, and other data-intensive services. Latency: offers lower latency compared to previous generation, enabling responsive communication for real-time applications such as online gaming and video conferencing. Multiple antenna technologies: 4G LTE utilize multiple antenna technologies, including MIMO, multiple input, multiple output, and beamforming to enhance data throughput and network efficiency. Backward compatible, 4G are backward compatible with 3 and 2G technologies, allowing older devices to connect to the network. Now let's go to 5G. 5G aims to provide only faster mobile broadband, but also support a wide range of use cases, including massive Internet of Things, critical communication, and ultra reliable low latency applications. Frequency bands operates in a broader spectrum, including the low-level sub 1 GHz mid-band 1 through 6 GHz and high-band millimeter wave or wave 24 GHz and above frequency. The use of wave enables extreme high data rates, but with stronger ranges and susceptible to obstacles. Data rates offers significantly higher data rates than 4G LTE, with peak speeds potentially reaching several gigabits per second. Enables faster downloads, improved video streaming quality, and support for emerging applications like augmented reality and virtual reality. Latency, 5G aims to achieve ultra low latency, reducing delay in data transmission. This is critical for applications requiring real-time responsiveness, such as autonomous vehicles and remote surgery. Network slicing introduces network slicing, allowing the creation of virtualized networks tailored to specific use of cases with varying requirements for bandwidth, latency, and reliability. Massive MIMO and beamforming expands on the multiple antenna technologies of 4G LTE, implementing massive MIMO utilizing a large number of antennas, and advanced beamforming for improved coverage and efficiency. Edge computing, 5G network facilities, edge computing, bringing computer resources closer to the network edge to reduce latency and support applications that require real-time data processing. In summary, both 4G, LTE, and 5G are cellular network technologies, with 5G representing the next evolution, offering faster speed, lower latency, and support for diverse applications beyond traditional mobile broadband services. The deployment of 5G is ongoing and expected to play a crucial role in the advancement of various industries and technologies. Next, we have NFC, near field communication. Is a short-range wireless communication technology that enables data exchange between devices in a close proximity. Here are the key features and characteristics of NFC. Purpose: NFC is designed for short-range communication, typically within a range of a few centimeters to a maximum of about 10 centimeters. It is commonly used for contactless data exchange, mobile payment, pairing Bluetooth devices, and accessing information with a simple tap. Frequency bands operates at the 13.56 megahertz, which is high frequency range. The use of this frequency helps balance the trade-off between range and power consumptions. Communication modes. NFC supports two main modes of communication. Active mode, which involves two power devices communicating with each other, and passive mode. One power device, which is the initiator, communicates with the passive device, which is the target, which does not require its own power source. Data rates. NFC supports relatively low data rates, typically ranging from 160 kilobits to 424 kilobits. While this speed is lower than some wireless communication technologies, it is more than enough for the intended application. Operating range. The typical operating range of NFC is very short, making it suitable for applications where close proximity is essential for communications. The short range enhances security and prevents unintentional data exchange. So use case, what do we use this for? Mobile payments. NFC is widely used for contactless payments, allowing users to make transactions by tapping their smartphones or contactless cards on payment terminals. Data transfer. NFC facilitates quick and easy data exchange between devices, such as pairing Bluetooth devices or transferring small files. Access control. NFC is used for access control system, allowing users to get entry to buildings or facilities with a tap of the NFC-enabled card or device. Information retrieval. NFC tags, which are passive devices containing information, can be embedded in objects or posters, Users can tap the NFC-enabled device to retrieve information or launch specific actions. Security. NFC includes security features to protect communications. This may include encryption and authentication to ensure that the data exchange are secure and not susceptible to unauthorized access. Compatibility. Many modern smartphones, tablets, and other devices come equipped with NFC capabilities. This widespread adoption contributes to ubiquity and NFC-enabled applications. Standardization. NFC is based on the international standard, including the ISO IEC 1443 and the ISO IEC 18092, ensuring interoperability between different NFC devices and systems. In summary, NFC is versatile and widely adopted technologies that excel in providing secure and convenient short-range communication for various applications, particularly those requiring quick and simple interactions with a physical touch or close proximity. All right, the last one is Zigbee. Zigbee is based on the IEEE 802.15.4 standard and is a wireless communication protocol designed for low power, low data rate, and short range communications. Here are the key features and characteristics of Zigbee. Purpose. Zigbee is designed for short range communication and low power, low data rate applications, making it well suited for, you guessed it, the Internet of Things. Devices, home and automation, industrial control, and sensor networks. Frequency band. Zigbee operates in the 2.4 gigahertz ISM band, the same frequency band as Wi-Fi and Bluetooth. It also has regional variations that allows operation in the 915 megahertz and the 868 megahertz bands. Range. Zigbee typically has a short to medium range, covering distance from a few meters to around 100 meters, depending on the power settings and the environmental conditions. This range can be extended by forming a mesh network where devices act as routers and extend the coverage. Modulation and data rates. Zigbee uses direct SQL spread spectrum for modulation. Data rates are relatively low, typically ranging from 20 to 250 kilobits per second, suitable for intermittent and low bandwidth communications. Power consumptions. Zigbee is designed to be energy efficient, making it suitable for battery powered devices. Devices can operate in low power mode and wake up periodically to communicate. Topology. Zigbee supports mesh networking, where devices can act as routers, forming a self-healing network. This allows for more extended range and improved reliability by routing messages through multiple devices. Application profiles. Zigbee defines various application profiles that specify how Zigbee devices should be communicated for specific applications. Example includes home automation, smart energy, and healthcare security. Zigbee includes security features such as encryption and authentication to ensure secure communication. It uses Zigbee Alliance key establishment framework for security. Interference. Zigbee use of 2.4 gigahertz band means that it may experience interference from other devices operating in the same frequency range. However, the mesh topology helps mitigate the impact of the interference. The Zigbee Alliance. The Zigbee Alliance is a consortium of companies that promote the development and adoption of Zigbee technologies. It oversees the development of Zigbee standards and the certification programs. In summary, Zigbee is a wireless communication protocol tailored for low-powered, short-range applications, particularly in the Internet of Things scenarios, where devices need to communicate intermittently by conserving energy. The mesh network capabilities and defined application profiles contribute to Zigbee's versatility in various industries. Now, with that said, this stuff will help you with both A plus and actually Network Plus, because Network Plus has a lot of this stuff also. So if you're studying for both exams, this will help you. This particular podcast will help you. And as always, ladies and gentlemen, if you're having trouble with your A plus exam, if you're having trouble passing, if you're having trouble, studying or concentrating, you could always reach out to me, Professor J-Rod, JROD, at gmail.com. I know I paid someone to be my social media manager, and she kept putting J-Rod, JAYROD, but the last couple of podcasts, I've been, making sure that I spell it right, and then I'm actually getting more emails from you guys, which is great. I love communicating with my fans. But again, I'm kind of want to do a day of question answers for A plus or Network Plus or Security Plus, whatever you want. We can do it, via Zoom or via something. I don't know. Thinking about doing a TikTok. You let me know. We can do it on TikTok live, right? If you want. I don't know. You let me know. Email me at professorjrod@gmail.com. That's JROD at gmail.com. See if you'd be interested in listening, right? If I do like we'll do 6 questions on, on live, on TikTok live, but I don't know. I don't have that many users. So, we'll see. Let's, let me know. Give me some ideas, guys. And let's expand this. All right, that's going to put a bow on today's episode. Thank you so much for listening. And since it's close to Thanksgiving, I want to wish each and every one of you a happy Thanksgiving. I'll see you next time. This has been a production of Little Cha Cha Productions, art by Sarah, music by Joakim. If you want to reach me, you can email me at Professor J-Rod, that's Professor JROD at gmail.com. You can also follow me on Instagram at Professor J-Rod.